Привет. Thank you. I have to say, it's always a pleasure to come back to Russia. So it's one of the favorite countries that I like to present about Java in. And I want to start the presentation with a quick poll of you, the audience. So who here is using JDK 8? Okay, good show of hands. Who here is using JDK 11? Anybody using JDK 12? A couple of people. 13? Almost nobody. Anybody using 7? A couple of people. 6? Oh, yeah, 1 or 2 people over there. Anybody using anything older than 6? 5, 4? No, I think you're waving to a friend. Okay, good. So the important thing is that Java is changing a lot more rapidly than we have been used to. In the past, we've been used to it being years between releases. Anything between about 2 and a bit years to 4.5, I think, is the longest period between releases. But now, as you know, we have 2 releases a year, 1 release every 6 months. So in this presentation, what I'm going to do is I'm going to take you through all of the changes that we've seen in the last couple of years, because obviously there's not lots of new features that have been added to the Java platform. And obviously plenty of you using JDK 11, but you may not be aware of all the things which have been introduced. So let's start by going back a couple of years to JDK 9. And the reason for this is that JDK 9 was a very important release in a number of different ways. Things changed at this point. And if we look at this, we can see there's lots of features that are listed. I think there were about somewhere in the region of 86, 87 JEPs that went into JDK 9. And Oracle were very clear when they released JDK 9, and they said this would be the last major release of Java. What they meant by that was the last release that would have multiple years of development behind it. Switching to a 6-month release cycle, obviously much shorter period of time, much less time to develop features. And if we look at JDK 9, obviously lots of features there, many of them quite small, some of them a little larger. But the one that's most important when we're considering moving from JDK 8 to JDK 9 or later, and that could be JDK 11 or it could be another JDK, is modularity. Now, I don't want to spend a lot of time talking about modularity because it has been around for a while, but it's worth spending just a couple of minutes to explore a couple of the things about modularity so we can be clear about how it impacts people from the point of view of migrating applications. Now, modularity you can really divide into sort of 2 sections. The first section is one which I consider to be a very sensible idea. And what modularity about there is the idea of taking standard class libraries that we have and breaking them up into more manageable units. Because if you go all the way back to JDK 1.0, there were 211 public classes that you could use to develop applications. And that was good, so you could do things. Move forward to JDK 8, which most of us are using, and you will find there are about 4,500 public classes in rt.jar. Now, as developers, that's great for us because it means that we don't have to write an array list class. We don't have to write a semaphore class. They're all there for us and we can make use of them. But the problem is that all of them have been added to one file. We have a monolithic library, rt.jar. And I can't think of a single application, and maybe this is a challenge for somebody, to write an application that uses all 4,500 of those public classes. So what we wanted to do in terms of modularity was to take those 4,500 classes, rt.jar, and break it up into modules. This made a lot of sense because if you think about Java, we already have groupings of classes. We group classes together that are logically related into packages. Modules is about taking that to the next level, where we group together logically related packages into a module. By doing that, we can then build a runtime for our application that only includes the modules that we need, not everything that is part of the Java platform. In terms of what ended up for JDK 9 was OpenJDK had 75 modules. So that's a good sort of number, which gives you a reasonable fine granularity without going overboard. I mean, you didn't really want 200 or 300 modules. 75 is about the right number. Of those, 24 are necessary for Java SE, which is the specification that says this is what you need to call something Java. There are 2 aggregator modules, which are special modules that don't contain any packages, but only contain references to other modules. Somehow, the smart card module also ended up in there. And it's a bit of a weird historical thing in terms of the way that Sun added things to Java SE. And then there are 48 JDK modules that relate to different tools, different parts of the underlying JDK. The second part of modularity is the more sort of contentious issue. What Oracle wanted to do was to take the internal APIs and encapsulate them. Because 4,500 public classes, there are also a number of internal classes that make those public ones work. Oracle and Sun before them have always been very clear about not using those for standard development. And the most obvious of those, the most sort of famous, if you like, is sunmisc unsafe. So who here has used sunmisc unsafe in their code? Ah, a good number of hands. Who here has ever used a third-party library or framework like Spring or Hibernate or Log4j? Yes, everybody. So you have used sunmisc unsafe. It's just that you don't know about it. And so Oracle wanted to turn off access to these internal APIs. And it turned out that that wasn't going to be practical. Too many people were going to be affected by that. It would break too much backwards compatibility. So when we move from JDK 8 to JDK 11 or JDK 13, we need to think about certain command line flags to enable access to these internal APIs. Now, I mentioned the idea of using modules to build a runtime for your application. To do that, the JDK provides you with a command called jlink. What jlink will do is create a directory structure and populate it in exactly the same way that you have the JDK that you install from wherever you get your JDK. And the way that works is you say, OK, jlink, then you can provide the path where you're going to find the modules that you want to use in your application. You tell jlink which is the module that is the main entry point of your application, and then where you want the output to go. So in this example, I'm saying my image is a directory, write the JDK to that. Once I've done that, I go into the my image directory and the bin directory and run Java, and I say list the modules. Rather than seeing all the 74 modules that make up the JDK, I'll see that in this case, I've got Java base, which I have to have, Java logging, Java SQL, Java XML. Only 4 of those modules are required for my application. And then I've got the modules that make up the application itself, Zap, Zoop, and Zeta. This is a really good idea because what we're seeing is this move to microservices, the idea of putting things into containers and deploying them in that way. So rather than having a central JDK that your containers need to reference, build a runtime specific to the service that you're creating, only include the modules you need, and then deploy that into the container along with the service. The nice thing about this is that you can massively reduce the space required for the JDK. A full JDK is about 350 megabytes. If you take the simplest possible application, hello world, it's less than 10 megabytes if you really strip everything out and only include the java.base module. So literally an order of magnitude smaller. Obviously, the more things you include, the bigger it gets, but you can see that it can be a lot smaller than the full JDK. So this is a big advantage in terms of moving to the module system. Now, the next thing about JDK 9 is the issue of compatibility. In the past, as Java developers, we have been very used to taking an application that was compiled on an older version of the JDK and moving it and running it on a newer version without having to recompile it, without having to change any of the code. And in fact, I was doing a blog post recently, and I actually found that you can take JDK 1.0 code that's been compiled and run it on JDK 8. Now, not everything will work. There are a couple of issues with some internal things, but pretty much, you can take JDK 1.0, run it on JDK 8. That's a fantastic level of compatibility. What Oracle have now said, and this is a direct quote from them, is that clean applications that just depend on Java SE should just work. Now, that's a little bit less than reassuring. I would like to say they will just work. But in this case, they are saying that there are some reasons why applications that are written on JDK 8 or earlier may not work on JDK 9 and later. The reason for that is that in JDK 9, in addition to modularity, there was another big change. And the change was the beginning of cleaning up the JDK. What had happened is that over the last 24-ish years, Java had developed. Many features had been added to Java, but pretty much nothing had ever been removed. What that meant was that Oracle were left with a huge amount of technical debt where they were having to maintain all these features, even though some of them had very few, if anybody, actually using them. And if you look at Java, it's had this idea of deprecation. In terms of the APIs, right from JDK 1.1, we had the concept of deprecating classes, interfaces, methods, and so on. And I did a bit of research, and you'll find there are about 450 deprecated elements in JDK 8. Of those, precisely 0 had ever been removed, which sort of begs the question of what's the point of deprecation if you never actually remove anything? So JDK 9 was different because things actually did get removed, and they got removed from the standard class libraries. Now, they didn't exactly go overboard in terms of how many things they removed. So JDK 9, 6 methods. That was it. 6 methods only in the standard libraries. They also removed a class, but that wasn't part of the standard libraries. It was part of the Java authentication and authorization service. And you kind of think, well, what did those 6 methods do that was so bad that meant they got removed and nothing else did? And it turns out that there are some very odd connections between different classes within rt.jar. And by removing those 6 methods, they were able to make a more clean separation of the modules that they introduced. They also removed a number of sort of redundant features, things like JHAT, the hprof agent, and some sort of garbage collection options that weren't really sort of relevant anymore. And JDK 9 has continued this. So JDK 10 has continued this. So they actually removed one package, 6 classes, 9 methods, and a field. But it gives you an idea that certain things are starting to be removed. And this is going to continue. So if you look at what's been deprecated so far, things like the CMS garbage collector, that's been deprecated. And the chances are it will be removed fairly soon from the JDK. Some people say, that's not such a good idea. We like G1, but we actually find that CMS gives us better performance than G1. And there was a discussion about this at the recent JVM Language Summit. And Oracle said, well, if you like CMS, are you prepared to continue to maintain it? And nobody put their hand up to say they would continue to maintain it. So it's kind of, okay, if you want to use it, you've got to do some work. Other things like Nashorn, PAC200, they've been deprecated. I would expect to see more things deprecated in the future. So what Oracle have now said is that compatibility is not guaranteed in the same way that it was before. They've said quite plainly that new versions of Java may include breaking changes. It's something you need to get used to. However, they have said that anything that they intend to remove, they will give us warning about it first. So they will deprecate any feature that they intend to remove at some point. And very generously, they have said they will give us a minimum of one release warning before something is actually removed, which is kind of good of them, because anything less than one release warning will be no warning at all. But what that means is that potentially it could be only 6 months between a feature being deprecated, let's say JDK 15, and it being removed in JDK 16. So this is something, as developers, we have to get more used to. Okay, so let's talk about how Java has evolved and the new features that we've seen in the releases since JDK 9. JDK 10. Now, this was the first release under the new 6-month release cycle, and so it didn't have very long in terms of development. So you can't expect there to be a huge number of features, but there were some interesting ones. So we have the idea of simple use of local variables and local variable type inference. This is the kind of code that we're used to at the moment. So I want to create an array list, and so I say array list of type string, user list equals new array list, and I can use the diamond operator to avoid having to put the type parameter, the generic type parameter, twice. Then I can do a stream of type string and retrieve the stream from the user list. And I can do other things, like I can have a for loop using string name over user list, and I can do for int I equals 0, I less than 10, I++. Okay, so this is all standard Java code, everything that we're used to. Now, Java gets var. So JavaScript's had var, so obviously it must be good, so let's add it to Java. Okay, maybe that's not a good enough reason for adding it. What we end up now is we can say var user list and var stream and assign those in the same way. Rather than having to duplicate the fact that we've got an array list or a list, we can say var user list equals new array list of type string. Now, I've highlighted the fact that string is in blue there, and that's because if you go through your code and you replace the explicit type with var, you have to be a little bit careful. If you're using the diamond operator, you get double type inference. So the compiler will infer that the fact that you're using the diamond operator, it has to infer the type, and without the type on the left-hand side, it will simply say an array list of object, and you lose that specific type that you have otherwise. So in this case, you need to remember to add or change the diamond operator so you've got an explicit type for your generic parameter. In the case of the var stream, userlist.stream, the compiler will infer for you what the types are. Important thing is this doesn't break any of the way code works. So this is not changing static types. It's purely getting the compiler to infer the type for you. And same thing with our for loops. We can do for var name over user list, and the compiler will infer string. With the older style for loop, we can say for var I equals 0, I less than 10, I++. It will infer int. Do not do that. There is no point in using var in that particular example. Var has 3 letters. Int has 3 letters. You're not saving yourself anything in terms of typing, but you're making it harder for people to understand what's going on in your code. So that's a bad example of using var. There are other places where var makes a lot of sense. So try with resources is a very good example. Now, I've deliberately made this a rather verbose example, but it gives you an idea of what happens. I want to create a buffered reader to use in my try with resources block. And to do that, I need an input stream and an input stream reader. And I've used the types, I've used the names, so I end up with a lot of text there. It could be quite hard to see what's going on. If we replace the explicit types with var, this tidies up, cleans up a bit. So now we can see, okay, we've got input stream reader, buffered reader, and it just makes the code a little bit easier to read, a little bit easier to understand when you're trying to see what somebody's doing in their code. One important thing about var is it is a reserved type, not a reserved keyword. So what does that mean? Well, it means that var can still be used as a variable name, which is good because it could potentially break a lot of backwards compatibility, which means that you can do this, var equals new value-added reseller. That will work. What you can't do in JDK 10, but I know that none of you ever would, is create a class with var as a lowercase v. So you could have done this in JDK 9, but you wouldn't have done. But now in JDK 10, because var is a reserved type, you can't create a type called var with a lowercase v. But of course, you can still create var as a type with an uppercase v, and that will still work quite happily. So those are just a couple of things to be aware of with that. Now, JDK 10 had a number of what are called JDK enhancement proposals. And I'm not going to go through all of them here. What I've done is I've picked out a few which are sort of more relevant to developers and might be more interesting. First one is the idea of adding a full GC phase to G1, which is parallel rather than only single-threaded. Some people had complained that when G1 had to do a full GC, it was a lot slower, and compared to the parallel collector. So the developers said, okay, we can make that phase parallel, divide it into a number of threads, and have that work more efficiently. Second thing is application class data sharing. This was a commercial feature in the Oracle JDK prior to JDK 10. What this does is allow you to have your application start up more quickly. How this works is that when you start an application, JVM has to read the classes for your application. So it reads the class files, and it creates some internal data structures to represent the features of those classes. When you start up the application again, it does exactly the same thing. Reads the class files, creates the internal data structures. Application class data sharing says, when you've started that application, write those internal data structures to an external file. The next time you start it, rather than reading the class file and building those data structures, simply map that file into memory, point the JVM at that area of memory, and it can start up straight away. The other advantage of that is that because the area of memory that's being used is read-only, you don't have to modify it, you can share that amongst a number of JVMs running the same application and reduce the resources required by your application. Third thing in JDK 10 was the introduction of an experimental Java-based JIT compiler called Graal. Now, the use of the term Graal gets confusing because you have the Graal VM and you have the Graal JIT compiler. Now, I don't know why Oracle decided to call the Graal VM Graal, because it just gets confusing. It's actually the substrate VM, but anyway. So what they did in JDK 10 was introduce this JIT compiler written in Java with the idea of producing better, more heavily optimized code as a replacement for the C2 JIT compiler that was there before. And then the last one in terms of JDK 10 JEPs was one that was contributed by Intel, who've been developing non-volatile RAM, which is as fast to access as dynamic RAM. What they wanted to be able to let people do was to put their heap on non-volatile RAM or dynamic RAM, and that's what this JEP allows you to do. A few new APIs in JDK 10. There were actually 73 new APIs, but I, again, didn't list all of them. Several of these are related to the idea of unmodifiable collections. So there are now new static methods on the list, set, and map interfaces called copy of. That will take a collection and return an unmodifiable version of the collection. So you can't change the elements in it. Similarly, for the Streams API, the collectors utility class now has 3 new methods which will return an unmodifiable list map or set from the input stream. And then the last one I picked out here is the optional or else throw method, which does exactly the same thing as get. It just has more letters in it. So I don't honestly know why they did that. Some people say, well, it's more explicit about what it actually does rather than get, but I still use get. JDK 11. Now, JDK 11 is the current long-term support release. Long-term support is the ones which have extended support associated with them, extended updates. Important thing there is that's a concept introduced by Oracle. It doesn't apply to the OpenJDK. OpenJDK only gets updates for 6 months. It's up to the people who compile the OpenJDK into a binary to determine what long-term support actually means. Now, in terms of what you get in JDK 11, one very small language feature was an extension of where you can use local variable syntax. And they extended it to lambda parameters. Here's an example of a lambda expression in use. So I'm mapping my stream, and I'm saying that the lambda expression takes a string and maps it to the lowercase string. OK, that's good. We already have type inference here. That was a big thing with lambda expressions and streams, was the fact that we don't have to explicitly state that S is a string. In JDK 11, we can now use var. So we could do this. We can say var s to lowercase s. And you go, why would I do that? What possible reason would I have for adding var in that case? And the answer is you wouldn't. There's only one reason why this feature has been introduced, and that's if you want to use an annotation. Because if you want to use an annotation, you can't annotate on something without a type definition. So you can either use the explicit string s, or you can use var and let the compiler infer it for you. So it's just a sort of syntactic sugary kind of thing. JDK 11 introduced the idea of launching single file source code. Now, up until JDK 11, we've had 3 ways of being able to launch a Java application. The first is using the class path, and we specify which class we're interested in. So you go Java main, and it will then execute whatever main is in our class. You can also do that from a jar file, so you can do java-jar myjar, and as long as it's been set up correctly, you can execute from that. With the introduction of the module system, there's the third way, which is using the module path rather than the class path. You can do java-m on a module. In JDK 11, they introduced a 4th way of launching a Java application. So now, if you have a single source file, you can say Java, in this case, factorial.java. The JVM will look at that, and it will say, hang on, factorial.java is not a class file. Doesn't have the necessary magic number at the beginning. It's a Java source file. I will then compile it, running Java-C on it, generate the class file, and then execute that class file, assuming that it doesn't have any syntax errors. The idea behind this is to make it simpler for people to get started with Java. So if you just want to do some very simple things, rather than having to go through all the rigmarole of compiling code every time you want to do it, you can simply say, OK, change my Java file, and then execute it without having to do the compilation phase. Let the JVM handle that for me. And we can take this one step further, because if we create a source file and we use Shebang support, so we have #bang, and then where our Java executable is, specify a command line flag to tell it what level of source code we're dealing with, put our Java code in there, make that file executable, then what we can do is simply do /factorial for, and the underlying operating system, let's assume we're using Linux, will say, oh, OK, run Java on that. Java virtual machine looks at it, says it's Java source file, compiles it, runs it, and it just sort of simplifies things. So we're almost at the sort of scripting level with Java. Again, JDK 11 had a number of JEPs added to it, so again, I picked out a few that are sort of interesting here. First of these is nest-based access control, and this is related to a bigger project called Valhalla, which I'm going to talk about at the end. But in order for some of the things that they were doing with Valhalla to work properly, they needed to change the way that inner classes referenced variables in the outer class which had private access. So they introduced a new form of access control for that. The second one here is dynamic class file constants, which, when you look at it, is very confusing, because how can something be both dynamic and constant at the same time? Surely it's either dynamic or it's constant. And the reason behind this is that they wanted to make it easier for certain languages and compilers that are being written on top of the JVM for languages other than Java. In JDK 7, they introduced the new bytecode, invoke dynamic, which was to help dynamically typed languages being compiled into bytecodes run more efficiently on top of the JVM. Dynamic class file constants is another thing to help compiler writers for other languages. And essentially what it does is it says, you have a class file that has a set of constants in there. Rather than fixing that constant as part of the compilation process, we'll make it like a final variable. So you can set the value once, and then it is constant. So it's dynamic from the point of view that you can set it at the beginning, but then it becomes constant. That's how you rationalize both dynamic and constant at the same time. The epsilon garbage collector. This is an interesting introduction. It's a garbage collector that doesn't collect any garbage. So you kind of think, well, what's the point of that? And the reason really is this was introduced by Alexei Shiplev, who works for Red Hat, working on the Shenandoah garbage collector. It's really about testing garbage collection algorithms to see how efficient they are and what overhead they have. You run your application as a test using the epsilon garbage collector. It doesn't do any garbage collection. As long as you don't run out of heap space, you can monitor the performance. Then you turn on your new garbage collector, run the same test, and see what the difference is in terms of performance. And that way you can see what the overhead of your garbage collector is. HTTP client, this was just the sort of formalization of the HTTP2 API into the standard class libraries. Previously, it had been sort of a module which was a sort of test module that people could give feedback to. Now it is actually part of the standard. Transport layer security, version 1.3, that's just an update in terms of making sure that you have the best possible TLS version available. And then the last thing is ZGC, or as the Americans like to call it, ZGC, which is an experimental low-latency garbage collector. The idea here is to avoid a lot of the garbage collection pauses that you get with traditional garbage collectors by doing things in a different way. The thing I would say about that is it is very much experimental. I would not consider putting that into production. And if you read some of the postings on some of the JDK development aliases, you will find out why it is experimental and why you shouldn't put that into production, because just recently they were having a lot of issues with how they were dealing with safe points in terms of garbage collection and interacting with the JIT compiler. Some new APIs in JDK 11. So we have the idea of a null input stream or a null output stream, or a null reader and null writer. What this allows you to do is to say, I want to read from a null input stream, and I will always get 0 bytes. And if I want to send some data to a null output stream, I can send as much data as I like to it, and nothing will happen to it. At which point you go, I have been programming in Java for over 20 years, and I have never needed these. What is the point? And it's really to do with a similar kind of idea to /dev/null. And there are certain situations when you're using the Streams API and a more functional style of programming where having a null input stream or a null output stream actually does make sense. So that's the reason for that. Optional has a new method, isEmpty, which is the opposite of isPresent. So you can find out whether the reference you have within your optional is a null. String has come in for some new methods. So there are a number of things that they've added here. The first of those is blank. I think it's fairly obvious what that would do. There is a new method called lines. If you have line breaks within your string, then it will return a stream of the individual lines separated by those line breaks. There is a repeat method that will take a number and repeat the string that number of times. And then there are three methods, strip, strip leading, and strip trailing, which will remove white space either from both ends of the string, from the beginning of the string, or the end of the string. The observant amongst you will say, hang on, there's already a trim method in the string class. What's the difference between trim and strip? And the answer is how the method handles white space or interprets white space. In the case of trim, it uses a very simple definition of white space, essentially space, tab, new line. In the case of strip, strip leading, and strip trailing, they use the Unicode definition of white space, which includes a lot more characters that can be qualified as white space. Predicate has a new method called not. I think this is my favorite feature in JDK 11. So we've introduced a new static method on predicate, which takes a predicate. Okay, how does this work? Well, again, if we look at a simple example of using a lambda expression, we can say that we've got S, and what we want to do is filter, using our lambda expression, to say we want things which are not blank lines. Okay. We can replace that with predicate not, and then we'll use the method reference, and we'll say string is blank. If we then do a static import of the predicate not method, we end up with filter not string is blank. So it's just a little bit more readable, just easier to understand what's going on in your code. Yeah, see, I like that feature. Somebody else does too. JDK 11 removed some modules. So this goes back to what I was saying about things being removed. And I mentioned in terms of the module system that there were two aggregator modules. One of them is Java, slightly bizarrely named, java.se.ee. And this contained the modules that sort of related to some of the enterprise bits of Java that had ended up being included in Java Standard Edition. In JDK 9, these modules were turned off. They were still in the JDK, but when you compiled or ran your application, they wouldn't be visible unless you used a command line flag to turn them on. So you could still do it, but you had to do some extra work. With JDK 11, these things have finally been completely removed from the JDK. So Corba is gone. Anybody using Corba? No, I'm not seeing any hands. Okay, so I'm pretty certain that nobody is developing any new Corba code. Java Activation Framework, that's part of the Beans framework. XML binding, JAX-B, a few people probably still using that. And the one that does catch out a number of people is the JAX-WS, Web Services. And this is the old SOAP WSDL way of doing web services rather than the more modern RESTful web services. JDK 12, what did we get more recently? JDK 12 had some interesting features. So in this one, we got switch expressions, which is a change to the language. But this was very interesting because it was the first preview feature. And a preview feature is one that's not part of the standard. So it is in JDK, but it's not in the Java SE specification. And that in itself makes it a bit of an odd thing. To kind of clarify things and make sure that nobody got too confused, in order to use this, you have to turn it on explicitly. So you need to set a command line flag, either for the compiler or the JVM, that says enable experimental features. Now, if you look at the way that switch has worked up until now, it has been a statement. A statement is something that executes but does not return a result that can be assigned to a variable. The other problem with the switch statement is that the syntax of it was obviously based on the C programming language. And because C is much more a compiler, systems programming language, operating systems type thing, it works in a way that's really appropriate to those types of applications. But for general application programming, it makes it a bit kind of clunky. The fact that you have to have case statements separated, the fact that you have to remember to put a break after each case block, otherwise it will fall through to the next one. And I'm sure, I know I've done this. I have forgotten at times to put a break in, and you end up this very complicated thing where you can't find the bug because you think it should never go there, but it does. So we end up with switch expressions. Here's an example of how we would use switch in existing code. What we're doing is we're saying, I've got a variable called number of letters, and I want to assign that based on the day of the week. And so in essence, I'm using the switch statement as a multiple if, then, else kind of construct. So that I'm switching on the day, and I'm saying Monday, Friday, Sunday, number of letters is 6. Tuesday it's 7, and so on. But the syntax, as we can see, is quite bulky. There's separate lines for the case statements, there's breaks in there, we have to assign number of letters repeatedly, and so on. With the switch expression, this becomes a lot simpler. So now we can reduce that down in terms of the number of lines of code and make it easier to see what's going on. We make the assignment once. So we're assigning the result of the switch expression, which means we don't have to remember to put it everywhere, and therefore we can't forget in one place and put it everywhere else. The developers have discovered that there is a very useful feature, new feature, which is called a comma-separated list. So now, rather than having to have each case separate, we can go case Monday, comma, Friday, comma, Sunday. Wow, who'd have thought? And then they borrowed some of the syntax from the Lambda expression so that the right-hand side of the arrow operator is what is actually returned by the switch expression. So case Monday, Friday, Sunday, we return 6. Case Tuesday, we return 7, the same as before. But it really reduces the number of lines of code that we need. And we can still throw an exception if we need to in case of our default. Now we can actually combine old and new syntax. So we can have the number of letters and we can have separate case statements. But in this part, rather than using the arrow, they decided to use break. And then the number after the break would be the number that's returned by the switch expression. So it's, like I said, a combination of the old style and the new style. And then you can actually take it even further and you could have code blocks. So you can say case 1 and then a block of code, case 2 and another block of code. I don't really like this. It is getting really kind of complicated. I would much rather see the code that's in a block extracted out into a method and then make it easier to see what's going on. The thing to highlight here is the fact that you can reuse the variable x in different case statements, which you couldn't do before. So now variable x, you can use it in case 1 or in case 2, and that will work. Again, JDK 12, some selected JEPs. First of those is the introduction of the Shenandoah garbage collector, being developed by Red Hat, into the Open JDK. So that's now part of the source code and can be built as part of a JDK distribution. Interestingly, Oracle are not including Shenandoah in their binary distributions. They also updated some of the G1 garbage collector, again, to improve performance. So part of that is the idea of what's called abortable mixed collections. And so that's essentially saying if the garbage collector is taking a long time to process a phase of garbage collection, they can actually have the JVM say, hang on, it's taking too long, stop doing that, and go back to letting the application threads run. There are certain places where that's quite safe to do, and it will give you better performance overall in terms of the pauses associated with your application. Second thing was the idea of returning unused committed memory. In the past, when the heap space is allocated and it grows, it never shrinks again. So you allocate space for a heap, even if the usage of that heap shrinks down a lot, that unused space is not returned to the operating system. Now, in JDK 12, with G1, it actually is. So you actually do get better use of the memory in the machine. JVM Constant API is simply an API that allows you to work with the dynamic constants that were introduced in JDK 11. And the default CDS archive is class data sharing again. That was introduced in JDK 10. And all this does is provide a default archive for the standard class libraries. So you don't have to generate that yourself. Streams has a new collector. So this is quite a nice one. And this is called teeing. Teeing takes two collectors and a by function. And I've produced this little diagram to show you how that works. What happens is it takes the stream and it duplicates it. So the same set of elements from the input stream are passed to both of the collectors that you define. The results of those collectors are then passed as the two inputs to the by function, and the result is what you get from the collector. To put that a bit more into context in terms of what it actually does, here's an example. So I can create a stream of numbers, 145, 217. I pass those into collect, and I use the teeing collector. In this case, the first collector I'm going to use is summing double. So it's going to add up all the values on the input stream and give me a total. The second collector I'm going to use is counting, which will tell me how many elements I have on the input stream. Because remember, it duplicates the input stream, you get both sets of values. The by function then takes the sum and the number of values, as its two inputs, divides one by the other, and returns the average value. So it shows you how you can use teeing. Obviously, in this case, I could have done that with a single method call, but it's a good example to show how teeing actually works. JDK 13. So bringing us right up to date, because this was only released, let's see, what was it? No, week before last, I guess, or last week, sometime, fairly soon, fairly recently. Text blocks is the big feature in terms of JDK 13. There was an attempt to introduce this back in JDK 12, but it didn't quite sort of make it. So they introduced it in JDK 13 as a slightly different way of doing things. Text blocks says that rather than defining a string using a single set of double quotes, we can now use 3 double quotes, and anything after that will be treated as the string up to the next set of 3 double quotes. That includes new lines. So we can now have strings that go across new lines. Good example here, we need some HTML. So we can say web page, 3 double quotes, our HTML text, and then 3 double quotes to terminate that. If you wanted to have 3 double quotes inside your string, then you would need to escape at least one, the first one, or more of the double quotes. And then we can print out the result of that, and we'll see this. So there's 2 interesting things to note here. The first is there's this concept of what they call incidental white space. Because if you want to line your text up so that it looks good in terms of the layout of your code, you don't want to have the white space on the left there included in the strings that are generated, or the string that is generated by the compiler. So incidental white space is actually eliminated from this. And the second thing to notice is that by putting the 3 double quotes on the line after the closing HTML tag, you get an additional blank line. If you don't want that additional blank line, you can move the 3 double quotes up to the end of the HTML closing tag. Switch expressions. Okay, I already talked about this. Why have I come back to them? Interesting thing here is that switch expressions are a preview feature, meaning that they can be changed. They're not part of the standard. And this is a good example of how that worked. People said that using break as a way of indicating what value to return from the switch expression could be confusing, because you can use break with a label, and you can break to that label. Now, labels can't start with a number, so technically there is no syntactic problem there, but people didn't like it and they thought it might be confusing. Because it's a preview feature, the developers were able to take that input and say, okay, rather than using break, we will use yield. So now it's yield and a number, and that's what's returned by the switch expression. Just a small change, but shows the value of preview features in terms of being able to change things without them being part of the standard. JDK 14. So I'm getting ahead of myself now. So what would we like to see in JDK 14? Well, there's only one feature I want to cover here, which is helpful null pointer exception. And I can't spell exception. So anybody here never had a null pointer exception in their code? Yeah, okay, we all have, I know. And the problem is, you see, that if you do something like this, a.b.c.i equals 99, and something there is a null, what's going to happen is you get this, exception in thread main, null pointer exception. But you don't know. Is it A that's null? Is it B that's null? Is it C that's null? Don't know. Now, with helpful null pointer exceptions, you'll get something like this, where it'll say, exception in main thread main, cannot read field C because A.B is null. And that immediately gives you more information about what's going on, and you can suddenly go, ah, now I can fix the problem. I have to say, I'm on the Java SE expert group. I will feed back that applause to the... Right, just very briefly at the end, longer-term JDK futures. Now, we've talked about all these little small things that are being added, but there are a couple of bigger projects going on as well at the same time. So first of these is Project Valhalla, and Valhalla is about improving the performance of storage of data within Java. If you look at Java, right from the very beginning, it's not truly object-oriented because we have primitives. And we have primitives to enable better performance in terms of storage. Objects obviously give us all the good things like encapsulation, polymorphism, and inheritance. But this gives us some restrictions. So for example, generic type parameters cannot be primitives. We can't do an array list of int. That doesn't work. So what we need to do is an array list of integer using the wrapper class. But that has all sorts of overheads, because if we want to add numbers to our array list, we're going to have to go through auto boxing, which creates instances of integer objects, assigns the values to that. Then when we take the values out, we've got to unbox them, and we've got to do the overhead of garbage collection and so on. So it's really not very efficient in that respect. If you look at the most recent sort of write-up of how they're getting on with Project Valhalla, the idea is to introduce what are called indirect projections, where you will have this idea of an optional int with a question mark after it, which is essentially saying that we're going to do the same thing as an array list of ints, but we'll treat it as an object. So the storage underneath will not require it to be using a full object reference with all the overhead of that, but it will look like an object reference from the point of view of the code. So again, this is still very much in the development phase. Things could change. This is the most recent prototype that they have at the moment. The other side of this is what they used to call value types and is now called inline classes. And part of this is the introduction of 2 new bytecodes. So this would be a big change to the JVM. So there's 2 new bytecodes called default value and with field. Now, unfortunately, I don't have time to go through all of the details of this. This will be a whole nother talk. But essentially, what they're trying to do is to have something that codes like a class, but works like a primitive in terms of the JVM itself. So from the point of view of working like a class, it can have methods, it can have fields, it can implement an interface, it can use encapsulation, it can be generic. But it cannot be mutated. Now you might think, well, we already have that, because if you have an object with a final in it, that final can't be changed. You set its value once and it can't be changed. Except you can, because if you use reflection, you can change that value even though it's final. With inline classes, you will not be able to change it even with reflection. And by making it truly final, truly immutable, then you actually enable better utilization of the memory space underneath, and you can do certain things as optimizations. So it can't be mutated, therefore it also can't be subclassed, and it can't be synchronized on because it doesn't have the mark word in the object header. Project Loom. Again, this is another big project that they've been working on in terms of massive concurrency within Java. And the problem is that if you want to scale up to literally hundreds of thousands of threads, mapping each thread in the JVM to a thread in the operating system does not scale, does not work. What Loom's going to do is, it was going to be called fibers. And again, this is the sort of most recent thing that they've been talking about, is they're now not going to have a separate concept of fibers. They're just going to treat these things as lightweight threads. But they will have the same syntax, the same way of being used as the thread class. It's just that the JVM itself will take a number of these lightweight threads and map them to a single operating system thread. The JVM will be responsible for context switching. The JVM will be responsible for scheduling of these lightweight threads on top of an operating system thread. To do that, they're already using the fork join pool scheduler that was introduced in JDK 7 as part of the fork join pool. And really the big part of doing this is adding the concept of continuations to Java. And a continuation is essentially a context of execution for a particular action. So it's a set of code, it's a set of register values and so on that you can do context switching on. By doing that, having much lighter weight threads than we have at the moment, will use less memory, and they believe, in terms of the testing, that they can get very close to zero overhead for task switching. Okay, very briefly mention what we do at Azul in terms of our Java, because it's OpenJDK. So we have Zulu Community, which is our free distribution of OpenJDK, passes TCK. You can get JDK 7, 8, 9, 10, 11, 12, and 13 on a wide range of platforms, Windows, Mac, Linux, 64-bit, Windows and Linux for 32-bit if you want older ones, and even ARM 32 and 64-bit. Did I mention it was free? And then if you want to pay us money, we have Zulu Enterprise. But if you want more information on that, I'll talk to you about it afterwards. Essentially, it's commercial support in the same way that Red Hat do commercial support for Linux. And so just to summarize, since I've got a minute left, Java continues to evolve. We have now got a faster release cadence. JDK version every 6 months. Updates to access to updates is a consideration. That's a separate discussion outside of this. Lots of ideas in terms of improving Java. So things like value types or inline classes, as they're now called, fibers, or lightweight threads, as they're now called, syntax improvements. All of those types of things are going to make Java better. They're going to add the features that developers want for that. And so really with that, spasiba.